There it goes. Okay. Let's see. I'm going to pin Nicholas first. I can see. You're inside out?
Yeah, the inside's Hawaiian.
Oh, nice.
So.
All right. I'm going to pin Cassie. I can see.
I can't see Cassie.
I can't either, Cassie. It looks like a little bunny or something.
Oh, you want to see my camera?
Well, I was just wondering if you wore your clothes inside out.
No, they're. Oh, I forgot.
Okay.
I could turn them inside out though.
What happens if we don't?
Nothing.
Okay, that's good.
It's fine. Let me see. Nathan, are you inside out?
No, why?
It's inside out day.
Okay.
Yeah, if I'm the only one who turns inside out, my family's not going to believe me. They were like, your clothes are inside out. And I said, it's inside out day. But if you guys don't come inside out, they're just going to think I'm crazy.
Barely anyone did inside out day. I'm inside out.
Serena, are you inside out? Let me pin you so I can see you.
There, I have my shirt inside out. My shirt was on the kitty cat, but now it's inside out white.
I'm inside out too. It is kind of hard to tell, but cool. Very nice.
My shirt is inside out, but this is just a sweater.
I'm gonna open up our Google Classroom. Oh, it is open. Okay, good. I'm gonna share my screen for a moment.
Okay.
Maybe. Okay.
Pencil. There it is.
Okay. Can you see our Google Classroom?
Yeah.
Okay. So it says, hi class, are you ready for another week? This week will be short because we have off Thursday and Friday this week and Monday next week for Easter. With the first day being inside out day. So make sure you wear your clothes inside out. That was just a reminder I put on yesterday in case you were reading this. You have a new Sumdog challenge due Friday. And congratulations to Serena, who already completed it when I was looking at it last night. I also put a Kahoot in there for you to complete. It is the first one, so let me know if you have any trouble completing it. And
I completed it.
Down here, somewhere in here. Do you guys see it? It says a new assignment, Kahoot.
Mm-hmm.
Would be this one that has 6 students for you guys, I think. Do you see this? If you look at your Google Classroom, hopefully this came into yours.
You. Google Classroom. Right there.
Wait, it's on Google Classroom, Mrs. Palmer?
What's that?
Kahoot's on Google Classroom?
Yes. There's a link to it on Google Classroom.
Okay, sorry. I went to actually right to Kahoot.
The code is 0994531.
Yeah, so you'll put that in, and it's just something I was trying new, so I figured I would start trying it with you guys.
This is the first one.
Okay, I found it. Sorry.
Okay. That says 2 people turned it in already? I don't know.
That means I finished it.
Oh, you did the Kahoot already?
Yeah.
Oh, great. And Nicholas Willoughby must have also.
Sorry, I didn't know there was music.
I was confused about it.
Okay, yeah. So it's in Google Classroom. Okay, so you should be able to find it there.
Okay. So,
all right. Cedric, are you going to send me the answers to the worksheet that I sent to you? Remember, you gave me answers to Dante's work, and I need answers to yours.
Oh, that was Dante's work.
Yep, we talked about that on Friday.
Oh, I forgot.
I also have another thing. For some reason, I have Nathan's work. I don't know why I have it. Is Nathan on right now?
I think Nathan did it.
My Google Docs for some reason. I have Nathan's work. Let me show you guys. Give me a sec.
I'm not sure what.
Maybe it's shared with everyone.
No, it said I could work on it.
Let's see.
There's Matthew Bellino. Good morning, Matthew. We were looking at Google Classroom because there was a message on there that there's a new Sumdog challenge that's due on Friday,
Yeah.
and there's a Kahoot.
A Kahoot? When are we doing that? Or do we do that?
You just click on the link. It's in Google Classroom.
Here.
And we wanted to know if your clothes are inside out, Matthew.
What?
Are your clothes inside out?
No.
Okay. It's inside out day.
I'm literally the only person who did it besides you. Okay, here's what I see.
So Serena did.
Here's what I see right here. Nathan,
I think that's the Russia study guide.
it is. But why do I have it?
I don't know.
Nathan,
Nicholas Marks, I had yours too.
I wanted mine.
Let's see.
That's just not good. I'll stop presenting.
Okay. I don't know why that is.
Should I contact Mr. Gilger on that?
Yeah, that would probably be good. Okay. You guys had a little bit of homework to
Okay,
do
I'll
in
email him.
your workbook. I'm going to pull that up so you can look at it.
For 343.
Yep. Yep. So go ahead and open your books to page 343 so we can check that over.
Can I go grab a pencil really quick?
Yeah. All right. I think we were in module 12, right?
Yes.
Okay.
Listen to.
Alrighty. Can you guys see my screen, page 343? Do you need me to make it bigger? Go ahead and pin Mrs. Palmer so you can see the screen bigger. It should like keep it on there. Okay. So number 6 said the graph shows the relationship between the hours a soccer team practiced after the season started and their total practice time. How many hours did the soccer team practice before the season? 6 hours. And that's shown this point right here at when your x-axis is at 0. So that's before the season began. They had 0 total practice time yet. So before anything already happened, before they practiced for the season, they had 6 hours of practice time already. What are the two quantities? Do you guys remember I said quantities is the word that really bothered me when I was learning this? It just means like the two things being measured, okay? Hours practiced during the season is one, and then total practice time for the year is the other quantity, the other thing being measured. All right. We talked about dependent and independent variables. Independent would be your x-axis, practice time during the season. Dependent is your y-axis, total practice time for the year. Is the relationship between the variables additive or multiplicative? Okay, so you have to look at this. Well, 0, 6, 1, 7, 2, 8. So it's additive. The total practice increases by 1 hour as the practice time increases. So we keep adding 1. We're not multiplying by anything. If we were multiplying by 1, it would stay the same, right? So we just keep adding 1. Describe the relationship between the quantities in words. The total practice time for the year is 6 more hours than the practice time during the season. All right, so that's your part E. And it makes sense because we started with 6 hours when the season started. Okay, we had practiced some other time before the season started. All right, number 7 was a new problem. Multi-step. Teresa is buying glitter markers to put in gift bags. The table shows the relationship between the number of gift bags and the number of glitter markers. Okay. So, what is the dependent variable? Number of markers. All right, because that's your Y. Independent, number of gift bags. Is the relationship additive or multiplicative? Explain. Okay, so we have to look at our points. 0, 0, 1, 5, 2, 10, 3, 15. Matthew Bellina, what did you say for 7C?
Multiplicative.
Good. Exactly. Because Y increases by a factor of 5. You take X and you multiply it by 5. They want you to put that in words for the next section. The number of glitter markers is 5 times the number of gift bags. Do you have questions about that page at all?
Mm-mm.
Okay. We're going to move into the next section. All right, so open your book to page 346. Writing equations from tables. All right.
Oh, wow.
All right, we're going to go through this together. Are you guys still seeing my screen?
Yes.
Okay,
Yeah, I can still see your screen.
great.
What is this video?
You see that? The cheetah is the fastest land animal in the world. Hey, wait up! Not all animals move super fast. Some animals, like snails, move super slow. But have you ever really watched a garden snail? They might be slow, but they sure can cover a lot of ground. In fact, they could be the poster animal who slow and steady wins the race. Except the tortoise already claimed that title. Suppose you're meeting a friend at the park, but she's running really, really late. A snail on the move catches your eye, and you decide to do a little math homework to pass the time. You find out the snail moves about 55 yards in 1 hour, about 110 yards in 2 hours, and about 165 yards in 3 hours. After 3 hours, you give up waiting for your snail-paced friend and go home. What are the independent and dependent quantities in the snail situation? This lesson will show you how you can use equations to show relationships between two variables.
Okay.
How can an equation show a relationship between two variables? The table shows how much Armand earns for walking the walk, 2 or 2 dogs. Use the table to determine how much Armand earns per dog. For each column, compare the number of dogs walked and earnings. So how many dollars does Armand earn for each dog he walks? Select the amount.
Okay, so it's either 8, 16, 24, or 40. Cassie, how much does he earn for each dog that he walks?
8.
Okay.
Great job. Armand earns $8 for each dog he walks.
Okay, do you guys see that that's the answer for B
Write an equation.
on page
Link
345?
the dogs Armand walks to the amount he earns. Let E represent earnings and D represent dogs. Select the correct operation to write the equation.
Okay, Matthew Bellino. Are we going to add, subtract, multiply, or divide to get from 1 to 8, 2 to 16, 3 to 24?
We add. Oh wait.
Here's the correct answer. Since Armand earns $8 for every dog he walks, multiply the number of dogs by $8 to find his earnings. Now use your equation to complete the table for 5, 10, and 20 dogs.
All right.
Write the earnings for each number of dogs in the boxes.
Okay, Nathan, can you tell me what to put in the boxes?
So the first box would be $40, second box would be $80, and the third box would be $160.
Okay, and guys, this is what you're going to put right in your book on that page in the chart. Good,
Excellent.
good job.
Multiply the number of dogs by $8 to get $40 of earnings for 5 dogs, $80 for 10 dogs, and $160 for 20 dogs. So how are the two quantities related? Drag the two phrases to complete the sentence.
Okay, Serena, which one do you want me to drag here? Blank depends on blank. Where should they go, Serena?
Armand's earnings.
This one? Depends on that one?
Yeah.
Good job.
Right. Armand's earnings depend on the number of dogs walked. So to use an equation to show a relationship between two variables, decide how they are related and then write the equation.
Okay, so this
real-world
is the same
problem.
chart that's in your book on page
First,
346.
Analyze the information. You are given donation amounts and sale prices. Next, make a plan. A good plan to solve this problem is to make a table. Drag each sale price and its corresponding donation amount from the problem to the correct place in the table.
Okay. So where would these go? The donation will be 50 cents if a painting sales for, so we'd have to put them in like that. Is this one in your book? Don't remember that one being in there.
Great job. If the sale price is $200, the donation amount is $50. And if the sale price is $300, the donation. You can write an equation based on a table when there is no real world.
All right, here's the one we want.
When there is no real world situation to consider for an equation, we usually say x is the independent variable and y is the dependent variable. The value of y depends on x. First, Compare the x and y values to find a pattern. Remember to compare all of the x and y values. Select the constant that relates y values to x values.
Okay. Nicholas Willoughby, which one of these should go in the blank? X is 1, y is 0.5. If x is 2, y is 1. X is 3, y is 1.5. So each y value is half of x, 1 times x, 1.5 times x, or 2 times x.
It's half times x.
This one? There you go.
Correct. Each y value is 0.5 times the corresponding x value. Once the pattern is found, use it to write an equation expressing y in terms of x. Good job. The equation is y equals 0.5x. Try another one. Find a pattern, then complete the sentence to compare the values.
Okay, let's go with Nicholas Marks. Nicholas, each y value is blank, the corresponding x value. So 2 more than, 2 less than, 3 less than, or 3 more than.
It is number 4, 3 more than. 3 more than.
Good.
Right. Each y value is 3 more than the corresponding x value. Now use the pattern to write an equation expressing y in terms of x. Type the equation in the box.
All right. Cassie, what would that equation look like? I'll start you off. Y equals?
Y equals x times 5.
Look at, we're saying it is 3 more than. How do you write 3 more than?
I'm sorry. Y equals x plus 3.
That sounds good. And what they're just trying to show us is sometimes you'll see a table and there's no story behind it. So we just use the x and y.
Good job. The equation is y equals x plus 3.
Okay. All right, I'm going to get out of that. And this. And this. I'm coming back to you guys. Okay, let's just do a few on this page. Do you see at the bottom of page 346? Nicholas Willoughby, let's look at number 2. Look at your x and your y values. What would you write there for the equation? It'll always start out y equals, what do you think, Nicholas? Y equals, what are we going to do for that one?
Y equals x minus 2.
Good. That's it. Y equals x minus 2. All right, number 3. Serena, we have 10, 25. This one's a little bit harder. 12, 30, 14, 35. I think this one's a little bit harder because it's a multiplication one. So it's multiplying, Serena. How many times is y then x? Let's just look at the first one because the number 10 is easy to work with. We have 10 and 25. 25 is 10 times what? Like that's not going to be a whole number because it's not
2.5.
Yes, it's 2.5. It's not, it doesn't end in a 0. So y equals 2.5x. Good work, Serena. All right, number 3. We start at 5, we get a 10. If we start at 4, we get a 9. 3, we get an 8. Cassie, what do you think's going on there? Y equals what?
Y equals x.
Mm-hmm. Are they adding something or multiplying? So to check to see if they're multiplying, Cassie, I would do, all right, 5 times 2 is 10. So I could multiply that. But 4 times 2 is not 8. Or 4 times 2 is 8. It's not 9. And 3 times 2. So it can't be times. So it's going to have to be adding. What are they adding, Cassie?
X plus 5.
That's it. X plus 5. Right? And number 5, Nathan. We have 0, 0, 1, 2, 2, 4. So you have to decide, are they adding or are they multiplying? Y equals what, Nathan?
Y equals 2x.
Good. Y equals 2x. One of the really cool things that I noticed when we were doing this is now you guys are saying y equals 2x. Y equals 2.5x. And at the beginning of the year, even not that long ago, you guys would say 2 times x. You know, but now you're starting to speak algebraically. It's very nice. Okay. I want you to put an X on 347. But on page 348, at the very top, there's a problem number 6. Okay. And it's a little chart that they want you to fill in. It says when Ryan is 10, his brother Kyle is 15. When Ryan is 16, Kyle will be 21. When Ryan is 21, Kyle will be 26. Write and solve an equation to find this. And you have to fill in the chart. So you're going to put their 2 names in the chart first. Ryan and Kyle. Okay? That's going to go first. And then you're just going to say, okay, when Ryan is 10, Kyle is 15. So you're going to fill that in. 10 and 15. Okay? When Ryan is 16, Kyle is 21. Go ahead and fill that in on your chart. And it also says when Ryan is 21, Kyle will be 26. All right, so you got your chart. You can fill it all in, and you have to write an equation. Okay, so this time, instead of y and x, we're going to use k for Kyle and r for Ryan. All right, so we're going to say k equals r. And am I adding for Ryan's age? Or am I adding to get Kyle's age from Ryan? Or am I multiplying Kyle's age? Matthew Bellino. We're going from 10 to 15, 16 to 21, 21 to 26. What do I do?
You're adding 5.
Perfect. All right, so k for Kyle equals r plus 5. That's your equation. Good work.
We still need to figure out how old he will be when Ryan is 52. Because that was
Okay. So now that you have the equation, that should be easy, right, Nicholas? So what is Kyle's age if Ryan is 52? Can you do that for us, Nicholas?
Yes, 57.
Yes, good. The answer is 57 years old. Okay. Once you have the equation, then it's easy. Good work. Okay. I want you guys to do numbers 1 through 12. So it goes from pages 348 to 350. But I just want you to do 12 problems like this. All right, so you can write algebraic equations from tables. All right, you also have your Sum Dog Challenge and a Kahoot that's, due at the end of the week. And this is for tomorrow. The Sum Dog Challenge, you have till Friday, even though we have off school. Okay? And it's just 50 questions. And Serena, you finished that already, so good job. Right, do you guys have questions for me? Okay. Have a good day. Don't forget to go inside out before the next period.
Okay.
Bye, guys.
Bye.